Okay, Assalamualaikum warahmatullahi wabarakatuh. Very good morning. Okay, sorry for being late. Okay, can you see my um, PowerPoint? So if you can see my PowerPoint, please comment, um, can see the PowerPoint. Okay, so I will continue our lesson regarding the identification test to distinguish class of alcohol. So there are two tests to distinguish class of alcohol, which is the first one is Lucas test and the second one is hydroform test. Okay, so for Lucas test, first you need to remember what is the Lucas reaction. So this experiment actually we have already done during the practical test. So sorry, the practical class. So the Lucas reagent is the concentrated HCl and the NCl2 as the catalyst. So during the experiment, so the lab assistant is already prepared for you. So actually the Lucas reagent is the mixture of concentrated HCl and the NCl2 as the catalyst. Okay, so the general equation for the reaction between ROH is an alcohol, okay, with concentrated HCl to ZnCl2. So actually OH will undergo nucleophilic substitution with Cl. So OH minus is nucleophile, substitute with Cl minus in ZnCl2. So they are act as catalyst so that the reaction will become faster. So that can be RCl and H2O. So RCl is haloalkane. So the mixture of haloalkane and water. Okay. So the mixture of haloalkane and water. So haloalkane form is insoluble in water because haloalkane can form hydrogen bond with water. So when the haloalkane can form hydrogen bond with water, so insoluble in water. So that's why you will form a layer solution, form two layer, okay, or you will found the cloudy solution. So actually the cloudy solution ialah campuran antara haloalkane and H2O. Okay, so based on the experiment, so for if your alcohol is primary alcohol, so you will class your alcohol as primary when KOH attached to this carbon attached to one neighboring carbon, so another atom is H, so this is primary carbon, so this is primary alcohol. So if your alcohol is primary alcohol, so the solution does not turn cloudy, so even after heating. So for secondary alcohol, when OH attached to this carbon attached to two neighboring carbon, so another atom is H, so this is secondary carbon. So when secondary alcohol undergo reaction with Lucas test, the solution will turn cloudy within 5 to 10 minutes. Okay, for tertiary alcohol, so class of alcohol tertiary when OH attached to this carbon attached to one, two, three neighboring carbon. So this is tertiary carbon. OH attached to tertiary carbon is tertiary alcohol. So when a tertiary alcohol undergo reaction with Lucas test, so the solution will turn cloudy immediately. Okay, so I give you some um, equation related with the Lucas test. Okay, so for example, in our lab practical class, so kita gunakan 2 methyl 2 propanol. Kalau tak silap saya lah. So 2-methyl-2-propanol is a type of tertiary alcohol. Okay, tertiary alcohol, OH attested is carbon. So you need to put this equation in your lab report. So this 2-methyl-2-propanol react with HCl concentrated in ZnCl2. So OH will be substituted with Cl. So your product will be CH3, C, CH3, CH3. Actually, jadi Cl plus H2O. Okay, so kamu punya observation ialah cloudy immediately. Okay. Then you use tak ingat apa, tu butanol. So tu butanol is secondary alcohol reacted with HCl concentrated. ZnCl2 as your catalyst. Okay, OH substitute with Cl. Your observation is so your observation is the form after 10 minutes heating. Okay. Then you use CH3, CH2, CH2, CH2OH, which is N-butanol ataupun N-butanol, 1-butanol. So this one is primary alcohol reaction with HCl concentrated, heat, ZnCl2. So your observation is no reaction. So dia ini equation, so no reaction. So observation, no cloudy solution form. So I want you to put in the your lab report. Is the second observation test for alcohol is iodoform test. So iodoform test, the reagent is iodine. Okay, NaOH aqueous. So this is the purpose. So this is the purpose to do iodoform test. So to do iodoform test is to determine the presence of the structure of methyl carbinol. So what is the structure of methyl carbinol? A methyl group attached to carbon alpha. Okay. Methyl carbinol ialah bila ada methyl CH3 attached to carbon alpha. Carbon alpha, apakah carbon alpha? Carbon that attached to OH. So this is the structure of methyl carbinol. Okay, so this is a structure of methyl carbinol. Okay, so dia punya reagent. Iodoform test, the reagent is iodine in excess in NaOH. Okay, iodine berlebihan dalam NaOH. So methyl carbonyl cleavage will produce carboxylate ion. Carboxylate ion ialah C double bond O minus, and iodoform. Iodoform ialah structure iodoform ialah CHI3. So iodoform is a compound, dia ialah sejenis sebatian that give yellow precipitate. Okay, example. Okay. Okay. Example, give the structure of product in the reaction below. So this reaction, okay, 1, 2, 3. Sebenarnya dia ada satu phase kat situ tertinggal. 1, 2, 3, 4. Okay, so when this, so actually, so as I mentioned before, so iodoform is a type of oxidation reaction. So as I mentioned before, kalau oxidation reaction, dia mesti reaction that add oxygen and remove H2O. Okay, so example macam ni. So this is 2 butanol, so dia tertinggal satu H. React with iodine mesti in excess, mesti berlebihan. So in NaOH, NaOH ini ialah produce medium, basic medium. So what happen ialah actually dia akan remove water. This one dia akan remove water. Kemudian dia akan masukkan oksigen. So yang remove water ni, tempat yang dia buang water ni, dia akan jadi C double bond O. C double bond O kat sini. So dia akan ada bond cleavage kat sini. So dia akan jadi sebenarnya CH3. CH3, CH2. Okay, dia bond cleavage jadi C double bond O. Tidak balas oxidation O minus. Okay. O minus. Sebenarnya dia ialah jadi, dia bila dia clash kat sini, dia jadi OH. Macam tu. Tapi sebab dia dalam medium basic, so basic ini ialah base. C double bond OH ini adalah acid. So base dengan acid, dia tidak balas, dia akan jadi O minus. Jadi garam kat sini. Okay, plus CH3 akan combine dengan iodine, CHI. CHI. Sebab iodine, carbon, dia akan buat 4 bond. So CH3I. Since iodine is in excess, so dia akan do substitution, free radical substitution lagi. H akan tukar lagi dengan iodine, so dia akan tukar lagi sampai dah dia jadi, so from CHI dia jadi CH2I2, kemudian ditukar lagi another one hydrogen atom jadi CHI3. So pada masa jadi CHI3 ni, ini dipanggil iodoform. So iodoform ni, this compound dia bagi yellow precipitate. So selepas dia jadi form molekul CHI3, so dia dah tak bertukar lagi, dia akan stop jadi CHI3. Okay, kelas can you follow? Boleh ikut saya? Boleh faham? Okay, so if you don't have any problem or you do not have any question, so we will continue with phenol. Okay, so phenol is a type of a aromatic alcohol. Okay, so tadi dia dah cerita pasal acidity. Okay, so phenol. So phenol is a type of aromatic alcohol. Kenapa aromatic alcohol? Because they are OH functional group attached directly to the benzene. Okay. Okay. So for phenol, the nomenclature of phenol, saya dah ajar masa nomenclature of alcohol during our first lesson. So sekarang kita nak belajar what is the speciality of phenol. What is the speciality of phenol? Ataupun kenapa kita sibuk nak belajar phenol? Okay. So, phenol, acidity of phenol, alcohol, and water. So, according to Bossert-Lowry theory, an acid is a substance that can donate a proton. Phenol, alcohol, and water release proton and form conjugate base when dissociate in water. So, acidity is increased as proton H plus is more readily to be released as this is subjected to the stability of the conjugate base form. So, actually ni kita dah belajar masa first semester chapter 7. Okay. So during the experiment, so scientists found that the acidity of phenol is larger ataupun phenol is more acidic compared to water, compared to alcohol. So why? Okay, why? Why this phenomena is happen? Because water dissociate to produce hydroxide ion. So this is water. Okay, so air dia bersifat acid, dia mesti donate proton H plus. Okay, H okay. Acidity is about ability to donate a proton H plus. So this is based on Bossert-Lowry theory. Okay. So the more acidic the compound, semakin compound tu semakin berasid when the compound is more likely ataupun when the compound prefer to donate proton H plus. Okay, when dia prefer, so bila dia donate proton H plus, apa efek dia? Dia akan produce more stable conjugate base. Ini kita dah belajar masa chapter 7, sem 1. Okay, so kalau kamu ada acid, HA is an acid. Kalau dia donate proton H plus, ni tanda negatif ni maksudnya dia donate proton H plus, so dia akan jadi A minus. Acid when donate a proton H plus, pasangan dia adalah conjugate base. Semakin mudah acid HA ni donate proton H plus, dia akan bentuk satu benda yang lagi stable, so dia lagi berasid. Okay, so saya ulang ya, semakin mudah sesuatu acid, okay, the more acidic the compound when when the more compound is more likely or prefer to donate proton H plus, and dia akan produce more stable conjugate base, so dia akan lagi more acidic. Okay. Okay, so I go to the next page, before tu. Okay, so when water donate proton H plus, dia buang H plus, dia akan jadi OH minus ion. Ini ialah hydroxide ion. When alcohol, ini semua ni, dia bila when act as acid, bila dia bertindak balas sebagai acid. Bertindak balas sebagai acid by donate H plus. Okay. When alcohol donate proton H plus, so dia ni donate H plus, so dia akan jadi RO minus. Ini adalah alkoxide ion. When phenol dissociate proton H plus minus X plus, so dia akan jadi phenoxide ion. Okay. So hydroxide ion, alkoxide ion, phenoxide ion, this is tiga ni ialah conjugate base. Okay. The stability of conjugate base. So we found that phenoxide ion is the most stable compared to hydroxide ion, more stable compared to alkoxide ion. So why? Kenapa? Okay. Why phenoxide ion is the most stable of the three ions? So phenoxide ion is the most stable compared to alkoxide ion. Alkoxide ion ialah from island fatty alcohol, and hydroxide ion from water, because the negative charge on the oxygen atom can be delocalized around over the oxygen atom, and the benzene ring resonance stabilized. Okay. Okay, so let's say bila dia let's say this phenoxide ion, ini adalah phenol. Dia act as acid by donating H plus, so dia akan jadi phenoxide ion. Sorry. Okay. So sebab this negative charge, saya baru kata ni negatif, oksigen negatif. Oksigen negatif, dia boleh pindah daripada sini. So daripada sini dia boleh pindah dekat sini. So bila dia pindah dekat sini, so ini akan pindah dekat sini. So dia akan jadi oxygen is no more negative. Kenapa? Sebab dia dah buat double bond dekat sini. Okay, so double bond kat sini dah tak ada sebab carbon ni dah 1, 2, 3, 4. So dia pindah dekat sini, masih ada retain. So carbon ni ada 1, 2, 3. So sekarang carbon ni ada bercharge negatif. Dia ada 2 elektron dekat sini pindah. Okay, so kemudian negative charge ni dia akan delocalize. Okay, negative charge ni dia akan pindah dekat sini. So ini akan pindah dekat sini. So dia akan jadi. Okay, so yang ni masih retain. So ini new double bond. So carbon ni ada 1 H, 1, 2, 3. So negative charge tadi pindah dekat sini. So negative charge sekarang dah pindah dekat sini. Okay. So negative charge ni, okay. So dia pindah dekat So dia pindah dekat sini. So ini negatif dah pindah dekat sini. So dia akan jadi this structure. So sini. So carbon ni ada satu H. 1, 2, 3. So ni ada extra elektron. Okay. So kalau saya kata adakah oksigen bercas negatif, saya baru nak cakap oksigen bercas negatif, dia dah pindah dekat sini pada carbon, this carbon. Saya nak kata this carbon negatif charge, dia dah pindah pada this carbon. Saya nak kata this carbon is negative charge, dia dah pindah pada this carbon. So maksudnya negative charge pada oksigen tu tak fix. Dia can be delocalized. So this 1, 2, 3, 4, this 4 structure is resonance to each other. So resonance mesti represent dengan double headed arrow dan kamu kena buat bracket. Okay. So when phenol act as acid by donating proton H plus, okay, it will produce phenoxide ion. Okay, ini semua phenoxide ion. Ini ialah resonance structure untuk phenoxide ion. So this phenoxide ion is stable. So why stable? Because the negative charge, just negative, can be delocalized, okay, at oxygen atom and around the benzene ring. Okay. Okay. Kalau water H2O, dia act as acid by donating proton H+, dia akan jadi OH-. Okay, kalau kamu tulis label OH-, dia stable ke tak stable? Dia less stable than OH-, ni ialah hydroxide ion. So negatif ni pada oksigen ni, sorry. Because the negative charge cannot be delocalized. Okay. So kalau alkohol alifatik, alifatik tu bukan aromatic lah. Okay, example, contoh dia apa ya? Let's say ethanol. Ethanol lah CH3, CH2OH. Okay, dia act as acid by donating H+. So bila dia donate H+ kat sini, dia jadi CH3, CH2O-. So kalau sini ialah ethanol, sini dipanggil ethanol, hydroxide ion. Okay. Hydroxide ion ni, ion dia ialah less stable. Kenapa less stable? Because the negative charge, okay, because so dia ada CH3, CH2. Because the alkyl group CH3 Ini ialah ethyl is an electron donating ataupun electron releasing group. So bila oksigen yang bercas negatif ni terikat pada electron releasing group, apa yang electron releasing group akan buat? Okay, the electron releasing group will increase the electron density at oxygen atom. So, dia akan tolak elektron kepada oksigen atom. Dia menyebabkan oksigen atom ni sangat-sangat negatif. So kita sebenarnya nak kurangkan dia negatif sebab kita kalau boleh nak jadikan dia satu spesies yang neutral. Kita tak naklah dia semakin negatif. So bila dia increase the electron density at oxygen atom, so maksudnya this ion is the ethoxide ion very unstable. So bila dia very unstable, dia not prefer to be formed. Dia tak cenderung terbentuk. So macam mana dia nak terbentuk? Dengan cara dia, okay, macam mana cara dia nak terbentuk? Dia akan terbentuk bila ethanol donate proton H+. Maksudnya dia bertindak sebagai asid. So adakah oleh sebab dia nak prefer to form, maksudnya kat sini ethanol not prefer to donate proton H+. Sebab kalau dia donate proton H+, dia bentuk sesuatu yang less stable. So dia tak akan cenderung terbentuk lah. So bila dia nak prefer to donate proton H+, so that's why ethanol very less acidic compared to water and compared to phenol. Okay, are you clear? Okay. So let's continue. Okay. So let's continue this one is I have already discussed. This one also, this one sudah discussed. Okay. Chemical properties of phenol. So phenol will act as acid. Dia akan prefer bertindak sebagai acid. Act as acid, mesti dia akan do a reaction that donate H+. Okay. Do reaction by donate proton H+. So phenol react with alkali metal to give salt and hydrogen gas. So ini dah belajar form 4. So this one, alcohol will act as an acid. So this is a phenol. Dia jadi acid. So sodium is base metal. So tindak balas antara acid dengan base. So dia akan produce garam. So phenol donate proton H+. So dia akan jadi O-. Sodium jadi Na+. So this is sodium phenoxide. So sodium phenoxide is a type of salt and it will release hydrogen gas. So kat sini H ada 1, hydrogen gas H2. So kamu kena letak sini 1/2 to balance the equation. Okay. So phenol also can react with strong base such as NaOH and aqueous to give sodium salt and water. So samalah. So this is a phenol. phenol act as acid, and NaOH aqueous is a base. So reaction acid and base, it will produce salt and water. So phenol will donate proton H plus jadi O minus. Sodium hydroxide ada Na plus OH minus. So sodium will attracted to phenol side ion, produce sodium phenoxide and H2O. Okay. So since phenol is stronger acid than alcohol, phenol can react with both sodium and NaOH aqueous. So aliphatic alcohol is a weaker acid. Aliphatic alcohol can only react with sodium but not NaOH because sodium is a sodium metal. Sodium metal in solid is stronger ataupun base, the strongest base than NaOH aqueous. So NaOH aqueous also strong base, tapi kalau diikut kereaktifan dia less reaktif sebab kita dah rendahkan kereaktifan dia dengan cara larutkan dia dalam air. Okay, so general equation, so ROH is an aliphatic alcohol. Aliphatic alcohol tu maksudnya bukan phenol. When reacted with sodium solid, so okay, hydrogen donate proton H plus, so dia akan jadi R, okay, dia jadi R, O minus Na plus, sodium, ini alkoxide and hydrogen gas, so kat sini hydrogen, so sini ada 2, so letak sini 1/2, so this one is aliphatic alcohol also, maksudnya bukan phenol. React with sodium hydroxide, so as I mentioned before, sodium hydroxide is weaker base weaker reactivity compared to sodium solid sebab kita dah larutkan dalam air. Dan kita kata sodium hydroxide bukan strong base ke medium, dia ialah strong base, tapi dari segi kereaktifan dia less reactive than solid. Solid is very reactive. Okay, sebab dia ialah pure. So this one kita dah rendahkan kereaktifan dia sebab kita dah larutkan dalam air. So alcohol, aliphatic and NaOH, so there are no reaction. Okay, next phase is identification test for phenol. So this experiment also we have done during the lab practical test by using bromine water. So bromine water maksudnya bromine aqueous, bromine water lah. Bromine we dissolve in water. So phenol we add with bromine water. So actually bromine is in excess. So dia akan masukkan bromine pada kedudukan auto para. So auto ialah 1, 2, 3, 4, 5, 6. So this one is auto and para. So dia akan jadi 2,4,6-tribromolephenol. So the structure of 2,4,6-tribromolephenol is give the white precipitate. So I want you to write this equation in your lab report. Okay, so your last case is so this year we don't do this experiment. Okay, the previous year we do this experiment when phenol reacted with FeCl3 aqueous, so it will produce FeCl3 akan masuk dalam gelang kat sini, so dia akan jadi purple complex solution. So this happen only for phenol, So when phenol reacted with FeCl3 aqueous, it will produce purple complex, and this is the structure of the compound. So phenol react with aqueous solution of iron chloride to produce purple complex. Okay, so I can stop my lecture at 1 o'clock, but I didn't not plan to stop at 1 o'clock. Tapi maybe dalam 12:30. So we have about 30 minutes. I want to discuss the tutorial question regarding the chapter hydroxy. So since we just learned about phenol, so let's do some tutorial regarding phenol. So please open your tutorial book and please refer page SK2 and SK3 tutorial question. Okay. Give an IUPAC name for each of the following compound. So actually IUPAC nomenclature ni saya rasa kamu dah sepatutnya very expert sebab each chapter pun belajar IUPAC nomenclature. And I have plans to skip IUPAC nomenclature for the next chapter. Sebab saya rasa dah pandai kan. So tak apalah, ini kita bincangkan. So give IUPAC nomenclature for the compound. So this one is benzene as your parent. So OH bonded to carbon number 1, 2, 3, 4. So OH hydroxy will become your substituent. So the name for A is 1, 4 dihydroxyl benzene. Ataupun combination 1,4 is para sebab ada 2 hydroxy, para dihydroxy benzene. Okay, B. Phenol is your parent. As I mentioned, kalau kamu ada pilih substituent that bonded to the benzene as a parent, so the substituent need to be number as carbon number 1, 1, 2, 3. So identify this substituent. So this is the substituent of 1, 2, 3. Ada 2 nitol, 1 H, ini ialah substituent of iso. Iso berapa carbon? 1, 2, 3, 3 carbon, iso propal. So ini ialah 3 iso propal phenol, or combination 1,3 is methyl isopropyl phenol. Okay, so this one, phenol is your parent. OH at carbon number 1, so 1, 2, 3, 4, 5, 6. Ini pun, so substitute at carbon number 2, 4, 6. Kalau kamu clockwise, kalau anti-clockwise, 1, 2, 3, 4, 5, 6. Also 2, 4, 6. Kita tak kisah tak namanya kan. So ini ialah 2, 4, 6. Ada 3 nitro, tri nitro. So your parents is phenol. 2, 4, 6 tri nitro phenol. Okay, so this one dah banyak kali tadi saya cerita. Ini bila ada sodium, this one is phenoxide ion. So combination sodium ion dengan phenoxide ion, nama dia adalah sodium phenoxide. Okay, number 2. The structure formula of X is compound is shown below. So this is phenol, which is an aromatic alcohol. So kenapa aromatic alcohol? Sebab OH attached to the benzene. So sini OH attached to C. Walaupun C ini terikat dengan benzene, dia kita classify sebagai aromatic alcohol kalau OH attached directly to the benzene. So ini OH terikat dengan C, C yang terikat dengan benzene. So this side is aliphatic alcohol. So kita mesti tahu sifat aliphatic alcohol, dia less acidic than phenol. So first reaction is this molecule react with sodium. Okay, so sodium is a strong base. So actually this is sodium metal. Okay, so the first reaction is sodium, means this is sodium metal. Okay, sekejap. Okay. Yes. So I will continue discuss tutorial, question number two. So sorry nampaknya time saya lagi teruk daripada lain tulis. Okay. Um, Question number two, the structure for X react with sodium. In sodium, um, so sodium metal. Okay. Okay. So untuk A, kita boleh tulis tu dekat screen saya. Okay. Okay, kalau saya rasa saya stop dulu. So yang saya tak dapat habiskan tu saya akan record the video for you. So I think so that's all for now. Thank you.